Good morning. So today we're going to start a new chapter. It's called polynomials, and it's broken up into two parts. We are looking at it in the first half, adding and subtracting polynomials, and the second half, multiplying and dividing. All right? And now before we can get going, our first lesson is about terminology. So we need to develop a common language that we can talk back and forth that accurately represents what's happening here. All right? So polynomials is a part of a unit of math or area math called algebra. And you started learning about algebra in the last two grade levels. Polynomial algebra just uses symbols, and those symbols are like the letters X and Y's. And those letters X and Y's and Z's we called variables. Now variables are just placeholders for numbers that we just don't know the value of yet. So these letters are just numbers, right? And so in this lesson, we're going to talk about a couple terms that will help us talk about polynomials. Right? One of the words we're going to discuss today is what does the word term mean? What does the word degree mean? Right? And what are the names of polynomials? Right? So let's get started. So polynomials are made up of terms. Right? So what are terms? Now, this is an expression, a polynomial expression, right? An example of one, right? Now, terms within this expression are separated by addition and subtraction symbols. So what I want you to do is find the addition and subtraction symbols, and we draw a vertical line there. For example, we have a subtraction symbol here, so we're going to draw a vertical line here. And we have a subtraction symbol here, we're going to draw a vertical line there. And this one just doesn't happen to have any addition symbols. Now, what are the terms? The terms are the chunks separated by these lines. So we have a term here, a term here, and a term here. So altogether, we can say this polynomial has three terms. Term 1, 2, 3. Okay? Now, polynomials is a general name for an expression that sort of looks like this. Now, we have some specific names as well. So if a polynomial only happens to have one term, for example, like this, we call it a monomial. Monomial. If it happens to have two terms, like this one here, we have a subtraction symbol, we draw a line here, part 1, part 2, this is known as a binomial. Right? Two terms. Now, if it has three terms, like the example below, we have a subtraction symbol and an addition symbol. We draw our vertical lines. We have one chunk, two chunk, three chunks here. And so we have three terms, and this is known as a trinomial. Right? Now, we stopped giving special names after three terms. So if you have anything more than three terms, like for example here, we just give it a general name, polynomial. Right? So you do need to memorize these four names, right? You need to know that one term means monomial, two terms means binomial, three terms means trinomial, and generally these are all called polynomials. Right? To help me remember these, I think of bikes, right? So you usually start off riding a tricycle. A tricycle has three wheels, so we have the word tri here, right? Tri meaning three. Then we usually move on to a bicycle, meaning two wheels, so we have a binomial. So the only thing this analogy doesn't really work for is if you have a one-wheeled bike. Those are usually called unicycles, so it's not called a unomial, but it's called a monomial. So figure out a technique that you can use to help remember these names. Right? So what I want you to do is give the video a pause here and try to answer the question for example 1. First thing I want you to do is look at these expressions and tell me how many terms there are. Is there 1, 2, 3? Is there more than that? Count the terms in each one of these expressions. Once you figure that out, give me the name. What's a name? Is it a monomial? Is it a binomial? Is it a trinomial? Or do we just call it a polynomial? So give that a try. So I'm hoping you came up with these answers, right? First one has 1 term, so it's a monomial. Second one has 3 terms, so it's a trinomial. Third one has 2 terms, so it's a binomial, and so on. So now that we know how to count terms, we need to learn how to figure out the degree of a term. So we're going to look at this little section here of our notes. All right, I'm going to highlight it here. And over here on the side here, we've got a bunch of different terms, 3x, 5x squared, y, and 12. All these are terms. We're going to figure out how to find the degree of it. And it's relatively straightforward. So every term has a degree. And to find the degree of a term, we simply add the exponents of the variable. That's the key word, of the variable. All right? So we look over here. We got, first example, we got 3x. We look at the variable, that's our x, and what is its exponent? And remember from the first unit here that if you don't see an exponent, it means there is actually a 1. So this term has a degree of 1, right? There's only one variable, so there's no need to add anything. Next up is the 5x squared y, right? So once again, we're only looking at the variables, okay? And we're going to look at the exponents. So the x has an exponent 2, and the y has an imaginary 1 on it. So we add up the exponents. We have a 2 and a 1, so 2 plus 1 gives us a degree of 3 for this term. Now the last one, the 12, doesn't have a variable, right? A 12 by itself, it's called a constant, right? So it doesn't have a variable, therefore the variable doesn't have an exponent. So this has a degree of 0 because it doesn't have a variable. Now an expression, so this is how we find the degree of a term. Now for an expression, a polynomial, right, that can also have a degree as well. And to find the degree of an expression of a polynomial, what we do is we find the degree of every single term that exists in that expression. Then we take the highest one. The highest one ends up being the degree for the expression, for the polynomial. So we pick the highest one. So first step is we look at our expression and we divide it into our terms. So we have an adding and a subtracting line here. I'm going to separate this into chunks, right? And we have the first chunk, second chunk, third chunk. And we need to find the degree of each one of these terms, right? The first variable here is we have an x. Its exponent is 2. So it has a degree of 2. The second term, we find the variable, it's x. And it has an exponent of 1. Nothing to add here, only one variable, one exponent. So its degree is 1. Finally, we have R7. R7 doesn't have a variable. so therefore it has a degree of 0. So we got the degrees of each term in the expression. Now what's the degree of this expression, of this polynomial? It's the biggest number we just wrote down, the biggest degree, which is 2. So we say this polynomial has a degree of 2, right? So next up is example 2, right? Determine the degree of the expression, right? So you need to find the degree of every single term, then pick the highest one. So pause the video and give that a try. Now, hopefully you came up with these answers. So you need to divide the expression up into terms, and then find the degree of each term, and then pick the highest one. So first one was 2, second one was 2, third one is 1, then 2, 1, and 2. Okay, going on to the last a little bit of this lesson is expressions can be represented using models. And these models are called algebra tiles. For example, so we have this expression 2x squared 4x plus 3. Right? And this diagram down below here represents this expression. Right? So you can see there's 3 different shapes for the 3 different parts of this expression. So the first part is 2x squares, right? We have a x square here and an x square here. So we have 2 of these that represents the 2x squared. So a large square represents x squared. Now, the middle term, we have a 4x. That's represented by these rectangles. We have an x, we have an x, an x, an x. 4 rectangles, so represents the 4x. And finally, the 3 is represented by these small squares. These small squares, each one of them stands for 1. 1, 1, 1. So altogether, we have 3 1s, so that's 3. Now, if you notice that some of these shapes are black, some of them are white. That has to do if the number is positive or negative. Right? So black shapes represent positive numbers. White shapes represent negative numbers. So if we have a white shape, that actually means this is a negative x, a negative x, a negative x, and a negative x to represent the negative 4x we have there. Now if you flip over the page, on the back side, I've given you a legend here of what each one of these shapes stands for. You have the small square, the rectangle, and the large square. On an assignment or a quiz or a test, if I ever ask you to work with these shapes, I will give you this legend so you don't have to memorize what these shapes represent. That will be given to you. Right? So now look at example 3. I want you to take these shapes here and tell me which expression did it come from. All right? So pause the video and give that a try. So let's discuss these answers. On A, we have a single rectangle. It's white, so because of negative x, and we have 3 1, so our expression is negative x plus 3. For B, we have a square, so that's a positive x squared. We have a black rectangle that gives us an x, and we have 2 small squares, so each are negative 1, so altogether we have x squared plus x minus 2. Third expression here, we have 2 large white squares, so those are each negative x squared. We have 3 rectangles, they're all white, so they're all each negative x, and we have 3 of those. And we have 4 small black squares, each worth 1. So altogether we have 4 of those. So our expression is negative 2x squared minus 3x plus 4. And the final one here is we have large black squares, so each one of them are x squared. So we have 2 of those, and we have 5 small white squares, each worth negative 1. So altogether we have negative 5. So 2x squared minus 5 is our expression. That's it for this lesson. Give the assignment a try.